Hey all, welcome to the second lesson with implicit differentiation. If you are watching these out of order, I really strongly don't recommend that for especially these two because I'm not going to go over a lot of steps and we're just going to jump right in. So get yourself ready for notes and let's get started. So one thing that's really helpful with implicit differentiation are functions that you maybe know something about them, but you definitely don't necessarily remember how to differentiate them. And one that I run into a lot of times with my Calc 2 students are these inverse trig functions. And to be honest, I don't always remember exactly what they are. So the way that I do remember is I'm like, I don't know what sine inverse is, but I do know what sine, the derivative is. That's cosine. So I'm going to start by saying, well, this is just asking me for a function of y is equal to sine inverse of x. And since, as we said, we don't know the derivative of that, but we do know of sine, I'm going to just switch that around and say y equals sine inverse of x is the same as sine of y is equal to x. Right? We're just switching over here using our inverse rules. And then we will take the derivative. So d dx of this entire function. Now, here, sine, as we said, the derivative is cosine of y, and then using our implicit differentiation rule is y prime, and that's equal to the derivative of x, which is 1. So then with dividing, we get that y prime is equal to 1 over cosine of y. And since we know that y is equal to sine of x here, we can plug that in, and we can say y prime is equal to 1 over the cosine of sine inverse of x. Now, while this is true, this is probably not the function that you had memorized. And that's because we're going to do a little bit of sneaky algebra here. Because what we want is it's like, oh man, if cosine and sine inverse, if these were both the same, if this was sine and sine inverse, that would cancel out so nicely. Wouldn't that be great? Well, we can do that, but we're going to have to remember a little bit of our trig rules, namely how to replace cosine with sine. Now, a function I hope that you remember from previous years is that cosine squared plus sine squared equals 1. This is one of your Pythagorean identities. Now, we're going to be replacing cosine, so I'm going to solve for cosine by itself so that we know that cosine of x is equal to root 1 minus sine squared of x. And then what I will do here is I will use this fact that if I just want to replace these x's with what's inside cosine. So this is cosine of x. I have cosine of sine inverse, but I can substitute that right in. Again, apologies for the handwriting, but you got just a straight substitution of x for sine inverse. So then cosine of sine inverse is the same as root 1 minus sine squared of sine inverse. The sines cancel out, leaving behind a squared and an x. So this will be the one that you recognize more, is we replace cosine of sine inverse with root 1 minus x squared. And this is probably the derivative that you recognize for sine inverse is 1 over root 1 minus x squared. So this is a really long way to go through these problems. It's great practice, though of course it's very helpful to just memorize this table. That process is mostly if you get stuck. So we've got our sine inverse that we just did. Cosine inverse is that same function with a negative, and tangent inverse is 1 over x squared plus 1. Now, another piece of things that I'd just love to have you recall from previous years is that saying something's the inverse is the same as saying like arc sine. So here, if I have arc tangent, that's the same as tangent inverse. So you're going to run into those interchangeably. They're just synonyms. So in our next question, it says, find the derivative of f of x is equal to x times arctan of root x. So in this case, we have a product and a chain rule. So for this first term, the derivative is 1. For this second one, since it's tan inverse, it's 1 over x squared plus 1. But since we have root x inside, we replace this with root x, and then multiply that by the derivative of root x, which is 1 over 2 root x, using our polynomial rule. If you want to pause this and check that work, I strongly encourage you to do just that. Take your time. So using these rules, we know that using the product rule, that would be 1 times tangent inverse of root x plus x times this larger derivative here. And I just did a little quick simplification here of the root x squared, so to x plus 1. Now I'm going to do a little simplifying and combining. So I'm going to drop that times 1 from the first term, and then I'm going to have the denominator distribute over, and you can leave it like that, or you can rationalize the denominator by multiplying everything by root x. And I'm going to do the algebra there. And then in that fraction we can cancel an x out of every term, leaving us with the simplified answer of f prime of x is equal to tan inverse of x plus the fraction root x over 2x plus 2. Now our last example is we're going to talk about something a little bit different using implicit differentiation, and this is the idea of orthogonal or normal functions. Orthogonal and normal are synonyms, and they mean perpendicular. So you'll see those three words basically used interchangeably: orthogonal, normal, and perpendicular. If you remember, when we think about derivatives, we're talking about slopes. Perpendicular means that they have the negative reciprocal slope. So a slope m would be perpendicular or orthogonal or normal to a slope of negative 1 over m. So if we're looking at a question like number 3, it says show that the families, so this would be one family where c is a constant, or x squared minus y squared equals k, where k is a constant, show that they are orthogonal to each other. So meaning we want to show that they have this relationship. Now remember, showing that this is the relationship is the same as saying the derivative of 1, if they're orthogonal, then that will be equal to negative 1 over that same derivative. So this is what we're actually interested in working through. So the first step of this question would be to find dy dx on both families. So I'm going to start with this first family, which is the product rule. So x has the derivative of 1, y has the derivative of just y prime. So the derivative of this entire function would be y plus x y prime equals 0. If I solve for dy dx, since that's what we want to compare here, we subtract the y term over and then divide by x. So y prime is equal to negative y over x. Now in the other family here, this is similar to what we saw in our last lesson. So we are going to take each term separately. So the derivative of x squared is 2x minus 2y times y prime is equal to 0. Now again, we're going to solve for our y prime term, subtract over the 2x and divide by negative, so we end up with y prime is equal to minus 2x over negative 2y. This will simplify. These two cancel out, and we're left with positive x over y. So now we can show that these are in fact perpendicular, because negative y over x is the negative reciprocal of positive x over y. Please let me know if you have any questions about the second day of implicit differentiation in the comments, or make an appointment, or you can just shoot me an email, whatever works best for you. I'll talk to you later.